Hi, welcome to today's video. Today we are going to talk to you about the average rate of change with linear functions, but this actually works with all functions. So just a quick review. Let's get to the first page here. Functions are rules that give us outputs when we supply them with inputs. Often we want to know how fast the outputs are changing compared to a change in the input value. So what I'm talking about, this is the average rate of change of a function. Okay, we're going to start with a problem here. Max and his younger sister Evie are having a race in the backyard. Max gives his sister a head start and they run for 20 seconds. The distance they are along in the race in feet is given below, with Max's distance given by the function m of t and Evie's distance given by the function e of t. Okay, take a look at the graph that you see. Make sure that you guys notice how it's labeled along the axes. X is your time. This is your independent variable, and then your y value is your distance in feet. Our first question is, we're going to explain the fact that m of 12 equals 30, okay, and we're going to also find our response in the graph. So m of 12, so what that means is the number 12 is going to be your x coordinate. So we're talking about seconds, and we can go ahead and write that in, is after 12 seconds. Max is 30 feet from the starting line, okay, so 30 is your y coordinate. This is a good explanation. Notice I did not cut any corners or try and simplify this. This is definitely very clear. Now we're going to find our response on the graph. So we are going to start at 0, 0. We're going to go right to 12. Notice that our graph, it moves by 2. Our x intervals move by 2, and then we're going to go up. Those move by 5. So we have, again, find that on your paper, and we're going to circle this. So it's the circled point on the graph, and we can even write that in as a key, C circled point. If both runners start at t equals 0, how much of a head start does Max give his little sister, and how can you tell? And we're going to be writing this in function notation today. So very quickly, right here, we have Max's starting point, and so his sister, E of t, is the other line, and this is where she's starting, and Max must have given his sister a 20-foot head start. But the first thing we're going to do is we're going to talk about these ordered pairs. So, since, and then m of 0 is Max, equals 0, so the y coordinate, and Evie, E of 0, equals 25, okay? So we're using those ordered pairs in function notation. Max must have, Max must have given his sister let's spell that right. Sister, a 25-foot head start. Okay. Does Max catch up to his sister, and how can you tell? So this is, we're looking at the end of our graph. So I'm going to erase the beginning of our graph. We're going to take a look at the end of our graph over here. So does Max catch his sister? We'll go ahead and say no, Max does not catch his sister. And then the other part of this question is at 20 seconds, which is the end of the race. So we're talking about our x coordinate. His sister is at 60 feet, but max is only at 50 feet. So, again, when we are explaining, we are going to include both the x values and the y values, okay? So again, my x value is 20 seconds, my two y values are 60 and 50 feet. And then the last part, part D, oh, I'm sorry, the next part, how does Max run during the 20-second race, or how far does he run, how far does Evie run, and what calculation can you do to find Evie's distance? So in the 20-second race, Max ran 50 feet. So Max ran 50 feet in 20 seconds. Evie, she runs only, and what we're going to have to do is she ran for a total of 60, but she started at 25 feet, so we're going to do a simple calculation of subtraction for a total of 35. That right there is my work for my calculation. So she runs only 35 feet. And that's because she had the head start of 25 feet. And ends at 60 feet. Okay. Part E. How fast do both Evie and Max travel? In other words, what are their speeds in feet per second? Express your answers as decimals and attached units, okay? Most of the time they will not be decimals, but when I tell you to do it in decimals, that's when you will. So we did this once before. It was Unit 2 functions notes number 2, where we had to calculate the speed of how fast a man was climbing down a ladder. Same thing that we're going to do here. So Max's speed. So he ran a total of 50 feet. Okay, we know this that we figured out earlier in a total of 20 seconds. And I know last year from 7th grade, you guys know how to calculate rate. So top divided by the bottom. So we have 2.5 feet per second. We're going to do the same thing for Evie's speed. Evie ran a total of 35 feet in 20 seconds. Again, we're going to take the top divided by the bottom, and she runs 1 7/75 feet per second. Okay, so again, even though Evie won the race, Max was running faster. All right, let's flip over our notes. So in this very first exercise, we were calculating the rate that the function's output values, the y values, were changing when compared to the function's input, or x values. This is known as finding the average rate of change. So that's what we ended example number 1 with. This finding the average rate of change is finding the slope of a line, okay? And we're going to be doing this a lot in this new unit of linear functions. So, average rate of change, here's your formula. Remember that y equals f of x. So the average rate of change, that f of x changes from x equals a to x equals b, is given by, okay, this is f of b minus f of a over b minus a. In other words, how much the y values have changed versus over how much the x values have changed. So that is the same thing, okay, if you know the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. A lot of times you'll hear me saying a shorthand, rise over run, okay? But we're going to go back, we're going to try and focus on our function notation as much as possible because I don't want you to forget it from the last unit. So for part A, we're going to consider the function. Okay, so we are given an equation. F of x is equal to x squared plus 3. We're going to find its average rate of change from x equals -1 to x equals 3. Okay, we're going to carefully show our work. So we know that the x values are going to change from from -1 to 3. We now have to first figure out our y values, and this is pretty easy. So we're going to start with f of -1, and we're going to substitute -1 in for x and solve. Okay, so -1 squared is 1, 1 plus 3 is 4. And I'm going to do this again for f of +3. Okay, we're going to substitute 3 in for x. 3 squared is 9, plus 3 more is 12. Okay, now we're going to use the formula that was given to you inside the box. Okay, I'm going to use m because we are talking about slope, which is another way of saying average rate of change. My y value of f of 3 minus f of -1, okay, over 3 minus -1. So all I did was I did the substitutions that you see in the box. And now we're going to do a few more calculations. So f of 3 we found is 4 minus f of I did that backwards. I apologize. F of 3 we found is 12 minus f of -1 is 4. Okay, 3 minus -1, those are my x values. We don't need to substitute for that. We can actually simplify. So again, 3 minus -1 is 4. 12 minus 4 is 8. We're going to carry over that 4, and that simplifies to 2. So the average rate of change for that equation is 2. Let's try this again. This time I have a different function. F of x is equal to 4x plus 5. We're going to find the average rate of change from x equals -2 to x equals 4. Again, we'll carefully show our work. We're going to first find our corresponding y values if x is -2 and x is 4. So our function notation, we're going to start with f of -2. We are going to substitute -2 in for x and simplify. 4 times -2 is -8. -8 plus 5 is -3. We will do this again for f of 4. Substitute 4 in for x. 4 times 4 is 16. 16 plus 5 is 21. Now we are going to substitute these values into the formula that was given to us. So we will be finding f of 4 minus f of -2 divided by 4 minus -2. Now, we know what f of 4 is. F of 4 is 21 minus f of -2 is -3. So we're putting in the actual y coordinates for f of 4, f of -2. For my denominator, I can go ahead and do 4 minus -2. 4 minus -2 is 6. We get 24 divided by 6. 24 divided by 6 is 4. That is what we get for part B. Now we're going to do average rate of change when we are given a table. So we are given function h of x. Okay, h of x is just, it's telling us it's a different equation. It's given in this table. We're going to find the average rate of change over the interval x is less than or equal to, 2 is less than or equal to x, which is less than or equal to 6. So I'm going to go ahead and start by just putting this information into my formula. So I'm going to start with h of 6 minus h of 2 over 6 minus 2. Okay, so again, we're going to find the change. We're going to find the difference. Okay, so it is your change of y over your change of x. Now we're going to use our table to find h of 6. So when our x value is 6, our y value is 3. When our x value is 2, our y value is 9. Okay. So that's what I'm using. So again, when my x value is 6, my y value is 3, minus, from the formula, when my x value is 2, my y value is 9. All divided by 6 minus 2. 6 minus, and then we can go ahead and simplify. We have negative 6 over positive 4. We're going to simplify again to negative 2/3. We're leaving all of our values into fractions unless it's otherwise noted. Okay? Let's try this again with a table. We have the function g of x is given in the table. We're going to find its average rate of change over the interval. Negative 2 is less than or equal to x, which is less than or equal to 8. Again, the first thing I'm going to do is when my x value is negative 2, my y value is negative 5. When my x value is 8, my y value is 15. I'm just going to mark that. So I know when I make my substitutions where to find those values. So I'm going to start with the substitutions of the formula. G of 8 minus G of 2 over 8 minus negative 2. Okay, makes our substitutions, start simplifying. Remember, G of 8 is 15. G of negative 2 is negative 5. Okay, remember the minus carries over from the formula. And 8 minus negative 2 is 10. 15 minus negative 5 is 20. 20 divided by 10 is going to be 2. And then the last thing that we're going to do here is we're going to find the average rate of change when given a graph. The function f of x is given in the graph below. We're going to find the average rate of change between the following points. We're going to show calculations that lead us to our answer. So the first thing we're going to do is very similar to the table where we are going to find x equals negative 6, and we are going to find the corresponding y. So on my graph, where here is negative 6, and then x equals positive 4. Right over here. So I mark those in blue. So, and I could even write it right underneath. So like I said, my y coordinate was I don't think I have my answer key right. That's all I'm looking at. Is positive 1. And for 4, my y coordinate is also positive 3. Okay, so let's start with the formula. So I'm going to start with f of 4. So my change of y's minus f of negative 6. And we are just doing 4 minus negative 6. Now my substitutions. So f of 4 we said is 3 minus f of negative 6 is 1. Over 4 minus negative 6 is 10. 3 minus 1 is 2, so now I have 2/10. I can simplify that to 1/5, again, as a fraction. Okay. Let's try this again for B. Same thing, I'm going to start with x equals negative 2. At x equals negative 2, my y coordinate, it looks like 1, 2, 3, negative 3. And when x equals positive 2, my y coordinate is negative 1. Okay, now let's put this into the formula and simplify. So it is going to be f of 2 minus f of negative 2 over 2 minus negative 2. To keep simplifying, f of 2 is negative 1 minus, that's in our formula, f of 2 is negative 3. So just putting in the corresponding y values. So you can always think of it as y2 minus y1 over x2 minus x1, which that simplifies to positive 4. Negative 1 plus 3 is 2. 2 over 4, and that simplifies to 1/2. Okay, hey, that's it for these notes. I will see you guys next time in class.